Thank you. All right, hi, my name is Maxime Beauchemin. I'm a data engineer at Airbnb, and today I'm going to be talking about Airflow. Let me get my clicker. All right, so Airflow is an open source platform to programmatically author, monitor data pipelines. Airflow is an orchestrator, or it is a workflow engine. It is used to process batch jobs, and it can process very complex workflows of jobs in the Hadoop, in and out of the Hadoop ecosystem. It is an orchestrator, so Airflow does not necessarily do a lot of work. So that's why I put on this slide an orchestra director. So Airflow makes sure that the symphony of all the tasks that you are running run at the right time and properly. So a little bit about me. So I've been working in data for about 15 years at a bunch of companies, and I've worked using a lot of the packages out there to do what we used to call ETL, and more recently we call data pipelines. So I started my career at Ubisoft, where I learned all the data warehousing and kind of data modeling and business intelligence, kind of traditional fundamentals. I joined Yahoo when it was the infancy stage of Hadoop at the time. And thinking back, back in the days, I never could have foreseen that Hadoop was going to become something this big. It's kind of amazing to think about that today. I remember just writing some pig scripts and MapReduce scripts, our jobs, and we would have to wait for 24 hours for these scripts to run, and we would end up getting like a cryptic bad error message at the end. So it used to be very painful, and now we're in a very dynamic place. It's amazing to see how the ecosystem has grown, right? We have a lot of vendors now, and I think like what's really amazing is seeing a lot of companies just sharing code based on goodwill, right? There's no, there are companies selling things, and there are just some really good engineers working at a lot of companies sharing code out of goodwill, and this is what Airflow is, right? So at Airbnb, we built this tool, and we thought it was a good opportunity to share back to the community, to the Hadoop community. So more recently, I joined Airbnb, and when I joined Airbnb, they were clearly kind of outgrowing the solutions that they had at the time, and we looked into the different solutions, and that's when we decided to build Airflow. All right, so the problem statement. What is the problem that Airflow is solving? So companies grow nowadays to have very complex networks of processes, and people who work with data write batch jobs, and there's a lot of batch jobs. It doesn't take that many people for that much time to get under a mountain of batch jobs that need to run every day. And the dependencies are really intricate, and these processes are evolving quickly. Batch processing now is, it is mission critical, right? People need their data. The data warehouse needs to run every day. All of that is mission critical. And a lot of people at companies spend a lot of time making sure their jobs run every day, and a lot of time is wasted, and it can be frustrating sometimes to just get the processes and just get all the data crunching jobs to run every day. So this is a very heavy slide. I'm not going to go through it, but most companies are behind in terms of workflow management, right? It is a pain point for most companies. People are frustrated with the tool that they use, and it's just companies become a victim of the things that they've built over time. And the typical symptom of that is your data engineers, your data analysts, your data scientists will spend most of their time doing kind of operational workload. So that means instead of writing new jobs and doing what you should be doing, you're just trying to make the stuff that you've built run every day. So here, and if you don't really have a good framework for your workflows, you have all sorts of symptoms and pain points, and you don't know why a job is not running, or why when it ran with the wrong data set. You can't figure out who's the owner of a certain process that you depend on. So this is all things that Airflow helps, problems that Airflow helps solve. So I mentioned this a little bit earlier. So when I joined Airbnb, they were clearly outgrowing the current solution they had at the time. There's a lot of pain point. It shows as SLAs that are not met, right? The data lands much later than it should. It shows as like bad data quality sometimes. And they knew, and we knew at the time, that we needed something much better to organize our workflows. And we had high hopes. I was coming from Facebook at the time, where we were doing some pretty advanced, like cutting edge analytics as a service. We were building pipelines dynamically. We had all sorts of services, like an anomaly detection framework. We had aggregation frameworks and different automation level around generating pipelines. And we were looking for an environment where we could do all of these things. And as we look, at Airbnb, we have people coming from pretty much every company in the Valley. And we asked people around, what should we use? What have you used before? And it sounded like most of the solution out there, people were not happy with. And we thought it was a great opportunity to build something new, build something that people would love. I knew it was possible because coming from Facebook, people at Facebook loved their workflow engine, and they used it every day, and people saw it as a true productivity tool. So we knew we could build something solid that people would love working with, and we did. And we're using, at Airbnb, we use, mostly open source stack. We're really heavy on the whole Hadoop ecosystem. We use Hive, we use Presto, and we thought it was just a good opportunity for us to build something and contribute back to the community. So what do we use Airflow for? So pretty much all of our batch jobs that run every day run in Airflow. At the center of this is data warehousing, right? That's where there's a lot of complexity. We have, hundreds of tables that need to be processed every day, and we use Airflow to make sure that everything runs in time. We do all sorts of data quality check to make sure that we don't publish data that don't meet certain criteria. And then all different teams within Airbnb started using Airflow internally because they were delighted to find a good workflow engine. So even people coming from Facebook, people coming from Google, LinkedIn, they look at the stuff we were building and we're like, we need this, we want to use this platform. So we have people in the search team, in the growth team. We use Airflow to process our A/B testing experimentation framework. We're building solutions around a framework around anomaly detection. We use it for sessionization and email targeting. So this scale, so at this point, Airflow is not a system that does a lot of work, right? It will mostly wait for certain events to happen, and it will tell other systems what to do, right? We'll say, run this Hive job, run this Pig job, run this Spark job. But the Airflow workers are not taking huge workloads. So right now we have six nodes on AWS that are Airflow workers at Airbnb. And we have 6 nodes just because it's cheap, and we want to have a lot of headroom and no bad surprises in terms of someone pushes a big job, we want to have enough slots, more slots than we need. We process around 5,000 to 6,000 tasks every day. So those tasks are, in parts, mostly Hive job, Presto checks. Some jobs are just sensors waiting for certain things to happen. So that can be a file landing in HDFS, a partition to land in Hive. So this is roughly, what this workload represents. We have 30 people internally at Airbnb that have written pipelines using Airflow. And we have in the GitHub repository 8 people that contributed different fixes and patches and operators. I'll get into what operators are in a little bit. And different companies have heard about Airbnb. In fact, like someone from the audience just came talk to me and be like, we're using Airflow, I've got questions for you. So even though we just announced an open source officially Airflow last Wednesday, And there is a blog post, if you want to read it, if you're interested, that has similar content to the content in this talk that you can read. But I think this is going to become somewhat big in the Valley. I know that everyone coming out of Facebook will be looking for a tool similar to Airflow because they've been used to a tool called Data Swarm internally. And in terms of scale, we have no bottlenecks inside, right? We know we could run this thing at a much higher scale. There's a lot of headroom, so scale is definitely not a concern. All right, design choices. So as we set ourselves to build this tool, and there is a demo coming too. I know there's a lot of slides here, but I'll get most of this presentation will be a demo of the UI. But I want to set the context before getting into the demo. So design choices, we decided to build most of Airflow or all of Airflow is written in Python. So the same way that maybe English is the language of business, I feel like Python is the language of data, or at least it is a common denominator. A lot of people in the data world know Python. We wanted to have a clear focus on authoring. So Airflow is a tool built by data engineers for data people. We've built it thinking, let's make it really easy to author and maintain pipelines using Airflow. So we expose the right level of abstraction that you need as you write your workflows. It is programmatic, so this is an extremely important point that I'm going to get into a lot more detail about. So the tools out there that exist, right, the schedulers and the DAG, I haven't really explained what the DAG is, but a DAG is a directed acyclic graph. It's a different word that we can use for workflow. It is simply a graph in which you have arrows, so it's directed and it's acyclic. There's no loop within that graph. So so a lot of the tools out there there's kind of different categories of tools, but some of them are drag and drop, right? I attended a talk yesterday where a vendor was selling more of a drag and drop tool, and that is an option. While building Airflow, we wanted something programmatic. So we are programmers, data engineers, and data scientists at Airbnb are programmers. We don't want to drag and drop components. We want the full flexibility of a programming language so that we can create abstraction, we can create classes, we can derive classes, we can write for loops, we can instantiate pieces of pipelines and things like that. So it was really important that it would be programmatic. An alternative also to programmatic is in tools like Uzi and Azkaban, they are config driven, right? So you have to write code that writes XML or YAML, and then there's an interpreter that picks up that config and runs it somewhere. And I feel like with that approach, there is some things that can be lost in translation, and it's just less flexible and less direct. So I guess the programmatic authoring a pipeline is kind of a differentiator for Airflow. And as part of the demo, we'll see a very simple pipeline, and I'll show you what it looks like, what the Python code to author a pipeline exactly looks like. We wanted to have also a very rich CLI, right, the command line interface, to be able to perform any kind of surgery on a DAG. So sometimes you want to rerun a set of jobs for a date range and everything downstream of these jobs. So this is the kind of stuff you can do with the CLI. So you can run job, you can run some tests, you can backfill using the CLI. So you can fire up a web server. So the CLI is very rich. And the last point on this slide is that we wanted to have a very rich web UI to make monitoring pipelines as easy as possible and to interact with your pipelines and your workflows in the simplest way possible. So that leads me to the UI demo. So I haven't seen a lot of live demos as part of this conference yet, so I like to live dangerously. So here's the demo part, the live demo part of this presentation. Okay, I think it's because it's coming back. You got it? All right. So here, as you enter the Airflow web UI, you see a list of all the workflows. So here I have a slightly modified version of some of the metadata we have at Airbnb. So those are modified production pipelines. I obfuscated, so I have a demo mode in Airflow that will blur some of the components so that you can't see too much, but there's really nothing to hide here. So here we have a list of the different workflows that have been authored by different people at Airbnb. We have kind of a view of how many tasks have succeeded, how many tasks are currently running, and how many tasks failed. I can click on one, so I'll take a simple one at first. So you see the blur. So in the normal version is not blurred. This is the demo mode. So here we can see at the time I took this snapshot of the production database, all of these jobs were running. So we're looking here at the graph of dependencies for a single workflow. And it shows all the different tasks. We have a little bit of a legend here that shows what are the different types of tasks within this workflow. So we can see that we have an email operator, which is this last step. So every day when this job finishes, it sends an email. We have Hive operators, which represent just each one of these purplish nodes represent a Hive job. And then we have Hive partition sensors. Those are the ones that were running at the time where I took the snapshot. Let me see here. So yeah, these guys were running. Those would just wait for a source partition to land in Hive. And Airflow supports also having workflows within workflows. So this is the sub-DAG operator. And I can click on one and zoom into a sub-DAG if I want to, right? In this case, at Airbnb, we have this common design pattern in our pipelines where we will stage the data into a staging table, perform some data quality checks using a Presto check operator, which is one of the Airflow operators. And if we pass the test, we do exchange the partition into production. And then the job succeeds and the workflow can continue. So here, since we're looking at a single, we're looking at the graph view, we're looking at a specific run, right? So I can go and click and look at the run for the previous day. That would be right here, and we can see here that all the jobs have succeeded for that date. Now I'm going to pivot into the tree view. So the tree view is a tree representation of this same DAG, right? So it's just a different view, and because it is organized in a more linear fashion, we can see on the right a time series of all the status for all the different jobs. So that means if one job would have failed 5 days ago, you would see clearly like a red dot, say here, and everything downstream from that would not be processed. So this view is very helpful in terms of debugging, troubleshooting your pipelines that are late or that are not landing. You have these helpful little tooltips. Again, you have the legend. So now I'm going to get into the contextual menu for a task instance, right? So I just click on a task instance, and now I'm allowed to do different things with that task. The first thing is, since this is a sub-DAG operator, I can zoom into the sub-DAG. You have a question?
So is your job a DAG of tasks, or are you showing us a DAG of jobs?
The DAG, it depends like how you define jobs. I'm going to repeat the question. So it's whether the workflow is a set of tasks or a set of jobs. Well, it depends how you define these two things. But for us, the nomenclature is we call it a task. And then a task instance would be a specific task on a specific schedule. So I'm looking at a task instance here. And I'm allowed to go view the task details. If it is a templated script, I can see it rendered. I can look at the list of task instance for that task, and I can get to the specific log for that execution. So if I wanted to, I can get straight into a Hive log and see the Hive log for that day. I can also click Run and force rerun a task. So if the task has already succeeded, I would have to force it because Airflow won't let you rerun something that already succeeded. And I could force ignoring dependencies if I want to run a task regardless of whether its dependencies have run. I can also clear. So clear is a little bit unclear, but it means removing the status from a DAG, from a task instance, so that the scheduler will pick it up again. So if you do clear, if I was to clear this specific job here, I would remove the fact that it succeeded before, and the scheduler on its next run, which is typically every minute, would pick up that task again and run it. As you clear things, you can clear relative to the point where you are clearing. So you can say, I want to rerun this job and everything that depends on it, which is a very common use case, right? If you have a Hive job that ran on bad data, you want to rerun that job and everything downstream from it, well, that is very easy to do even from the UI. You could do it from the CLI as well, from the command line interface, but in the UI, it's very easily done. So say if I was to click this task here and say I want to clear everything downstream and future of it, it will show me what it's about to clear. And then I can clear it, and then the scheduler would pick it up again. And then I can mark success. So I guess clear and mark success are just different ways of fixing false negative and false positive. So marking success would say, this job failed, but I know it actually ran, or I fixed it some other way. Let's mark success here so that we can move on with the execution of this workflow. All right, so now since we have all this metadata as like all the tasks, when they started, when they ended, it's easy for us to like plot the task duration over time. So here you can see that very easily. You can see at what time, like how many hours after the schedule of the task the job finished. So you can see that some days, probably some table landed later. And you see clearly kind of the outliers in terms of SLA and what's delaying your pipeline. There's also this Gantt chart view, which is, now I'm looking at the Gantt chart view for a day that is running, or that was running when I took a snapshot of the database. So if I go look for a different date, I'll see more of a Gantt chart. So we can see we were waiting for a lot of Hive partition to land. And when the right partitions were there, then we have all these little tasks that ended up running. And then there's this code view, which is, it is not where you write code, but is where you can have it for reference and see what was the code that generated this workflow, right? So it's in context with the web UI. So if you're troubleshooting maybe someone else's pipeline or your pipeline, you might want to see, wait a minute, how was this generated? Or what is this specific setting? I think I skipped some things here, but I'll just go quickly into a Hive job and show that you can view the parameters for a specific task. So this is the code. This is some HQL code for a Hive job. I'll try to go quickly through it. But you see there's like some curly brackets in there. It's because we support templating as part of your job. So your jobs can use the Jinja templating language. I'll get into a little bit more detail about that, but that's the means by which we pass parameters to scripts, or one of the ways we can pass parameters to script. And at the very end, you can see more information about the settings of that specific task. Cool, so I'll just show a few more, slightly more complex workflows. So core data is like the pipeline by which we create the core part of our data warehouse every day. And it's a lot more complex than the one we just looked at. If you're looking for specific jobs, you can actually, search here, and it should, center on the job you're looking for. So that is another workflow. I wanted to show another one I have here. So this is our experimentation framework where we have a lot of A/B tests running at Airbnb, so potentially hundreds. And this is a pipeline that is generated dynamically using the metadata of the configuration of these A/B tests. So it might look like there's a lot of code behind this to create all these nodes and all these edges, but the code is actually very simple, right? There's just this much code. We can see that there's a little blurred. We like to squeeze some ASCII art in our pipelines at Airbnb. So that's something, if you decide to use Airflow, you should probably carry the tradition. To generate these hundreds of tasks here, all we need is this amount of code because we're looping through each experiment and creating a set of tasks for each experiment. This is something that if you'd be, I have no idea how you would do that with Uzi. Uzi or Ascamon, you would probably need to write code that writes a config file dynamically, right? Here is just, your code is a Python program. And because it is a Python program, you can loop through things, read metadata. You can say, hey, I'm going to read from a database a list of experiment, or read from a config file a list of experiment. And for each experiment, I'm going to create these steps. And maybe even based on the configuration, you might create or not create certain steps or create them differently. So you can do all of this using Airflow, and it comes very naturally. So this is the part of the presentation where I will show a little bit of code. So I didn't know what kind of audience I was going to have. So unless like anyone protests that I show some code, but I think probably you guys want to see a little bit of code to see what an Airflow pipeline looks like. Yeah, sure. If I'm going to be talking about errors that happen before a backfill? Yeah, I can try to address that, but it is extremely easy to do that with Airflow, right? Because you have the command line utilities, and even through what I showed in the UI, you can clear very easily a date range. And you can, in the CLI, you can run an Airflow clear command, which will take a task ID regular expression and say, clear this set of tasks and everything that is downstream from it. Then you can run a backfill command that will just run everything in the right order. So Airflow is really good at allowing people to perform any type of surgery on their DAGs, on date ranges, and on sets of tasks and dependencies or dependents. And I'll take questions at the end, too. I'm going to try to leave some time for that. So hopefully I can finish quickly so we have a bunch of time for questions. I will be outside the room here answering questions for as long as there will be people asking questions as well. So here is what an Airflow pipeline looks like, right? It is a Python program. You can see here at the top that we import the classes that we need, or the objects, for the objects we're going to create. So from Airflow, import DAG. If you're familiar with Python, we just import some objects. From Airflow.operators, operators are kind of task factories. So we import the bash operator, which is a very simple operator that will just run a shell script. And then we import some date things that we're going to need. Here we define a dictionary of default arguments, right? As we instantiate our task, we don't want to say every single time who the owner is or what is the start date. We want to define or kind of global defaults for the tasks. So this is what is done here. So we set an owner. Depend on pass is a feature that you can say a task depends on previous execution of that task, so that if it fails, you don't want it to run again. So that would be, say, like building a dimension from yesterday's partition of the dimension. If yesterday fails, you don't want to move on and keep building the dimension with the bad data. So so here we're setting it as a global default, and we can override it as we instantiate tasks. That we'll see a little lower in the script. We define a start date, so this pipeline should start backfilling from that date, so that when I commit my script into production, the scheduler will start from that date. We give an email. We say, please don't send me email on failure or retries. We set a number of retries, which we can also override for specific tasks, but in this case, we say retry once. We can define a retry interval that's defined as a time delta Python object. And then we can define, here I put this as a comment because they're arguments we don't use generally, or that I don't expect like people starting with Airflow using, but you can define, wanted to mention that you can define different queues, so different workers can listen on different queues. You can define pools to limit parallelism, so say if you don't want more than, 10 or 16 Hive jobs to run at once, you can define a Hive pool if you want and cap it. There's also priority weight that has to do with pool, so that when slots open in a pool, the higher priority jobs run first. Schedule interval by default is the day. but we have a lot of pipelines that run hourly. We don't really have a lot of things that run on a 5-minute. I would probably recommend to not go under 5 minutes. So it is not a streaming engine, right? Airflow is a batch processing workflow engine. If you want to do some streaming, you probably want to go with some other technology, right? But so this defines the schedule interval of your DAG, which is most likely day or hour. So we've defined now the default parameters. And we instantiate a DAG object, right? Very simple. So we say, I'm going to create a DAG object. That's the DAG constructor. We give it a DAG ID, and we pass the default arguments that we want to use. Pretty easy. Here we instantiate a bash operator that is very simple. It is just running the date command, and we'll return the Unix time date. We create another bash operator. This one sleeps for 5 seconds. And here I wanted to show that we can use templated commands. So this is the templating language that we use is called Jinja, and is baked into the Airflow engine. That's the means by which we pass parameters. So say when you run a job, you always have access to DS, and you have access to a set of macros and a set of parameters. And this tries to show how you would parameterize certain scripts. So sometimes it's really it's really useful in your SQL to have the workflow engine pass a few variables. So here we pass a rich set of variables, as well as references to the task and DAG object and all sorts of things you might need. And using Jinja, you can squeeze code logic. So here there's a for loop within a text file. And here there's another task. We create a third task with a different ID. We use the templated command. We pass a parameter. And that stuff will render into a proper batch script, right? In this case, that will have like 5. It will run this 5 times. And here we say which task is upstream from the other. Task 2, set upstream task 1. So we create the dependencies that way. Right, so it's pretty straightforward. Pipelining code is simple. We just define the task that we need, and then we define the dependencies between these nodes. So why do we need a drag and drop interface through that? So to me, it's just easy to write that code. The real complexity in your code is in your Hive script, your pig script, your bash script. The pipeline code itself is not much. So this is the tutorial. It is widely available. So I heard you guys, that people are interested can easily go to the Airflow documentation and run through the tutorial. It's also very easy to install Airflow. We've made it extremely simple. If you're familiar with Python, you can, or even if you're not familiar with Python, you can just pip install Airflow, and you've got a working instance you can fire up a web server and go through this tutorial, interact with it, use the command line interface, and it's very simple. So that's a selling point compared to things like Uzi, where if you try to install this thing today, you might be done by the end of the week if you have the right skill set. All right, so I think I'm ready to get back to the slides. All right, so I had all these, let's see, back to the clicker. So I had all these slides prepared in case of the live demo would not work. It did end up working. I skipped a section in the live demo, so maybe I'll just use this, the last slides here. So you see there's a little data profiling section that ships with the Airflow UI. It allows you to just run simple queries against your databases and see the result set. So it's just very useful for a data engineer, data scientist to be able to look at the data that they're working with. So we have that. And then we have a little charting application too, built on top of something called HiCharts, where you can write a little bit of SQL and pick a type of chart and visualize it and share that with colleagues. So it's kind of the cherry on top. It's not really part of Airflow, but we ship with it because we know people need that. And we use that every day, right? We need to visualize data. We need to browse through data sets. So you get that for free as you install Airflow. Here I was showing that there's an admin menu that allows you to configure your connections. So connections are managed centrally in Airflow, right? You don't want every single script to hard code the host names and login and passwords. So in Airflow, there's an array of connections that you define. through the web UI. You can see your configuration for your install. You can also manage your pools from this area. All right, so now we're back into the slides. I'm going to talk a little bit about the technologies behind the scenes. So we have a Python backend. So everything is written in Python because it's easy to write. It's super high velocity. It's easy to extend. We use a framework called Celery to distribute the work to the workers. So we needed a message queue and a way for the scheduler to tell workers what to do. We use a simple framework called Celery. Celery allows you to define different brokers or message queue. We use Redis. We've used RabbitMQ before. It all works very, very easily. You can have simpler setups of Airflow where you don't need to have all of this, right, at least to get going. We use the Flask web framework, which ships with SQL Alchemy. So those are all Python. SQL Alchemy is an ORM. On the JavaScript side, you saw some D3 in there, some nice animation. So there's D3 and high charts. The templating templating language is called Jinja. Is extremely powerful. It allows you to pass all sorts of parameters and macros and integrate them into your scripts. Metadata database for Airflow. We use a database to store the states of the different tasks, right? Airflow is stateful, and I was able to show all the little green square because they're stored in the database. And we use MySQL, but whatever SQL Alchemy supports, so you can use Postgres or different databases for that. For more information, you can look at the Airflow in the code repository that's open source. You can go and see the requirements.txt. There's a list of all the dependencies in there. So operators are task factories. So this is just a quick look on all the operators that we have. It is reflective of the stack that we have at Airbnb. You'll see a lot of Hive-related things in MySQL, Python and Bash, S3, Postgres. It's really easy to add on and create new operators. Those are the ones that ships with Airflow today. As we involve the community, we should see a lot more operators come up. There's kind of three types of operators. We have sensors that wait for event to happen, and when the events happen, it triggers whatever is downstream in the DAG. We have more execution operators that will tell another system what to do. And then we have transfer operators that will take data from a system and load it into another system. It's a pretty classic, simple things. There's also more general purpose operator like the Bash operator and the Python operator. You can do whatever you want to do, whatever you're allowed to do within a Bash script or a Python script. So quick architecture slide. So this is all the components behind Airflow. It looks very complex this way, but you can run all of this on a single machine. On the right side, I show how the workers interface with external systems. There's a web server component that you can run on multiple instances if you want to put a load balancer or some redundancy there. There's the scheduler that reads from the pipeline definition from the master repository of pipelines. And you can also work locally from a clone of that repository of pipeline on while you develop. You're still allowed to use Airflow in your local repository and get workers to do the work that you define in that clone repository. So I'm going very quickly now as I run out of time. My conclusion is like what we're working on now in the next step. There's a missing point here. I'm working this week on a plugin system to make it easy for people to add on to the web UI and integrate their code without having to go through code review or to get their stuff in the main Airflow repository. We're building a community, right? That's why I'm here. We're super excited to share. We're part of the sharing economy at Airbnb. We want to share this. We want to build a community. We definitely want to share. We're building a Yarn executor, so moving away or offering another option than running on Celery to talk with workers. So instead of having Airflow workers running Celery, we will have a Yarn executor where we push the workload to Yarn. That way we leverage the Hadoop ecosystem. And opening up to the future, we are building more complex, we're all building on top of this platform, more complex services and frameworks, and we'd like to share those eventually. So we have people, great data engineers at Airbnb working on anomaly detection, collecting stats from Hive tables and storing the statistics in a MySQL database. We're thinking about sharing our experimentation framework. So that's where this is headed. Once again, I repeat, it's super easy to install, so we've made it extremely easy to install and test drive. So if you're interested, please take a look. Questions? If you guys can go to the microphones, that would help, because this is videotaped.
Yeah, it's a nice talk. Thank you. My name is Sean from Yahoo, and I used Uzi before. I also using Azkaban before. So obviously, my question is, looks like some advanced or friendly feature from the Airflow can make the thing easier compared using Uzi and Azkaban. But you also mentioned this is just a workflow. So does not the whole thing a little bit overkill? Try to make the simple thing a little bit more complicated than necessary. That's my question.
So the question is whether Airflow is overkill?
Yes. For the feature that it cannot be easily supported by Azkaban or it cannot be supported by Uzi, it's not a little bit overkill, yeah.
Right, so you're saying that maybe we should have considered extending the code base of Uzi or Azkaban instead of building something new?
Well, that you say, I didn't say that.
So we looked into the code base of both of these systems, and we decided that it was a very bad choice for us to try to extend those tools, especially Uzi.
Okay.
All right, more questions quickly, or is that it for questions, or one more question, sorry.
I've got a really quick question. The question is, do you guys also have some kind of development guidelines for how to author the jobs? For example, you have this notion of clearing things, so that would imply that the jobs need to be built in such a way that they have rerunability.
Yeah, and then having an idempotent job is like definitely a design pattern that we strongly suggest, right? So that jobs can be rerunnable without creating problems. So when we design our different unit of work, we want this unit of work to be idempotent when we can. So that means that rerunning a job 5 times would create the same result 5 times, hopefully, and not create double loads and things.
Yeah, that's what I figured. I was wondering if there were any other kinds of guidelines along that line that maybe didn't get surfaced in the discussion.
Yeah, so the guidelines would be mostly like traditional, data warehousing practices and best practices around data engineering. Airflow, for that purpose, is really just something that triggers the job. So the normal data engineering best practice would apply.
Okay, thanks.